Welcome to Ask and Learn.
In this problem, we are asked to rework problem 3.11 using mesh analysis. Now in problem 3.11, we are asked to find for the current I1 and current I2. Now using mesh analysis, you could get three currents here as IX, IY, and IZ, where mesh IX gives us an equation of negative 24 plus 10 ix plus 40 times ix minus iy equals 0. So this is just the KVL across mesh ix. Now, we could write a super mesh that goes from the second and the third loops here. Now, we could label it as color red here for the super mesh. Using the KVL at the super mesh, we get 40 times IY minus IX plus 20 ohms times IY plus 30 times IZ plus 20 times IZ is equal to 0, 30 ohms. Now, we can simplify these equations as first equation being 25 ix minus 20 iy minus 12 is equal to 0. That is our first equation. For the super mesh, we could simplify it as 40 iy minus 40 ix plus 20 iy plus 50 iz equals 0, or 6 iy minus 4 ix plus 5 iz equals 0. Now this is our second equation. Since we have three unknowns iy, iz, and ix, we need three equations to solve for them. The third equation can be acquired using junction rule here at this node, let's say node 0. So at node 0, junction rule gives us I1 or IY is equal to IZ minus 5 amperes. Since IY here is to the right and IZ is to the right and the 5 amperes is upwards. So this is, or you could say IY plus 5 amperes is equal to IZ. Now, rewriting the equation, we get IY plus 5 amperes minus IZ is equal to 0. Now, this is our third equation needed to solve for the system of equations. Rearranging the equations, we could use matrix to solve for the unknown variables. The initial matrix gives us, for the first equation, 25, negative 20, 0 is equal to 12. For the second equation, we get negative 4, 6, 5, 0. Lastly, for the third equation, we get 0, 1, negative 1, and then 5. Now you could solve for this unknown using the determinants. So the determinant here, we get 25, negative 20, 0, negative 4, 6, 5, 0, 1, negative 1 as 25 times 6 times negative 1 minus 1 times 5 minus negative 20 times negative 4 times negative 1 minus 0 times 5 plus 0 times negative 4 times 1 minus 0 times 6. Now solving for the value here, we get the determinant of negative 105. Now to get delta Ix, we just substitute the values here in the first column as 12, 0, 5, and then copy the rest of the columns of the matrix as such. Negative 1. For delta Iy, we substitute it to the second column, giving us 25, negative 4, 0, 12, 0, 5, and 0, 5, negative 1. And for delta Iz, the third column, giving us 25, negative 4, 0, negative 20, 6, 1, and 12, 0, 5. Now solving for the corresponding values, we get delta Ix as 368, delta Iy as 577, and delta Iz as negative 398. Now we could solve for Ix as 368 over negative 195 or negative 1.89 amperes. Delta Iy as 577 over negative 195, that is negative 2.96 amperes. And delta Iz as negative 398 over negative 195, giving us 2.04 amperes. Now I2 is just equal to Iz based on our circuit. Hence, I2 is equal to 2.04 amperes. Now to get I1, we look at the current passing through the resistor 40 ohms. Based on the mesh, we know that I1 is equal to Ix minus Iy. Substituting our known values for Ix and Iy, we have a negative 1.89 minus negative 2.96, giving us a value for I1 as 1.07 amperes.